Hi everybody, my name is Henry, and today we're going to introduce one of the basic concepts in physics, and that is angular momentum. Okay, so have you ever wondered why you don't follow the bike, or why an ice skater can rotate so fast and so stable, or why an helicopter has two propellers? All these things are reasons of angular momentum. So, what is angular momentum? Angular momentum is a vector, and it has magnitude and direction. The magnitude of angular momentum is relative to the object's mass, the object's speed, and the radius of the object. And how about the directions? Well, we can judge the direction by simply use the right-hand rule, which means your right hand fingers is the direction of the rotation, and now your thumb is the direction of angular momentum. Okay, so angular momentum is describing what will an object behave, what will an object do when the torque acting on it. So angular momentum causes the change of torque causes the change of angular momentum. So there's no torque, the angular momentum is conserved. So it will lead to some interesting phenomenon, and our group mates will present you some of them. Okay, thank you.
Hello everyone, my name is Chen Pu, and I'm the freshman of Department of Physics. And now I want to briefly introduce about the application of angular momentum in our life. In fact, many things concerned about rotation has the concept of angular momentum. And now I want to take helicopter as an example. When a helicopter's propeller rotates clockwise, according to the conservation of angular momentum, the body should also rotate counterclockwise. But in that case, the pilot cannot drive very, very carefully. So, in case that happens, that's why we need a tail rotor. The tail rotor, it can create a powerful flow, and it can also create a torque that is clockwise. So it can keep the body from spinning. In other words, the helicopter can rotate it without the body spinning. Yes. And beside upon, we can also find the principle of angular momentum in ballets or the figure skating, and even small as the internal atomic structure or the planets around the stars. So let's explore it in our life. Thank you.
Hi, now I want to talk about some physical knowledge easily. First, we talk about the conservation of angular momentum. Every of you might see the figure skating. When a figure skater closes his arm to his body, when he rotates, the speed will out. And conversely, if he puts his arm out of his body, then the rotation speed will be slowed down. In fact, this phenomenon is about the conservation of angular momentum. We can use a formula to explain it. And what is the moment of inertia? The moment of inertia is like a mass. If the mass becomes higher, then it will be more difficult to be moved. And likewise, it solves the moment of inertia. And therefore, we fix the mass and decrease the radius. And because of the conservation of the angular momentum, the angular velocity will be more quickly. And let's take a small test to prove what I said. Hi, let's make a small experiment. And I have been talking about the figure skating. So look at me carefully. Do you see? When I close my arm to my body, then the rotate speed will be more quickly. And if I put my arm all over my body, then the speed will slow down.
Hello everyone, my name is Yang Shixuan, and I will talk about the conservation of angular momentum. In a system which if subject to combined torque is zero, this system will angular momentum conservation. We have to explain the experiment. A person is holding a counterclockwise rotation of a wheel. To make this wheel, which of when the moment of inertia is accordance with right hand rule, the direction is up. And when he moves to the half, the entire 180 degrees flip the wheel. We will find that this time, the direction of the angular momentum of the wheel is down. This time, take the time this person will rotate counterclockwise rotation of this person will provide a system and upward angular momentum to maintain conservation of angular momentum of this system. The concept of conservation of angular momentum is also used in many parts of life, such as helicopters, ballet. Thank you everyone.
And we want to demonstrate this experiment. We first let this wheel rotation. And then we turn it 180 degrees. And we see this motor turn the counterclockwise to rotation. And with this conservation of angular momentum can be maintained.
Hello everyone, now I would like to show you the common phenomenon, which is called precession. Okay, now I let the wheel rotate on my hand. As you see, it seems to have another axis while it revolving on its own axis. And the top is another example in our daily life. So what caused the action? The gravity is the reason. The gravity will exert a torque on it, and the torque's direction is vertical to the previous angular momentum at any time. So, this relationship will trigger an interesting event. The torque will give rise to the change in the direction of the angular momentum of the wheel. So, it behaves as it has another axis. By the way, our Earth has a similar action too. Okay, thanks for listening.